Welcome to Spring LIB.
Right, so this is question 28.54, where we have a solenoid that's a torus, and we know that the current in the windings is 2.4 amps. We know the number of windings, we know the mean radius, which I've converted here to meters, and we know that the magnetic field inside the windings is 1.94 Tesla. We also know that now there's some magnetic material inside of the solenoid, and we want to figure out the magnetic susceptibility and the relative permeability of the material that fills the solenoid. So this is our normal equation for the magnetic field inside of a toroidal solenoid without any magnetic material inside. So the only difference that we have now is that we need to replace our mu naught here, that's the permeability of free space, with Km times mu naught, because we now have this factor of this extra permeability due to this additional magnetic material. So for part A, we're just asked to solve for Km. So we can just rearrange this equation so that it's solved for Km. So let's start by bringing the 2 pi r over to the left side. So we get this in the numerator. And then we want to divide by these 3 terms for the denominator, and that's going to give us Km. So all we have to do now is just plug in all our values. We have B, 1.94, we have R is 0.25, mu naught is a constant, and N and I are also both given. So when we plug this all in, we should solve and get Km is equal to 2021. So now that's the answer to part A. Now for part B, we're asked to solve for the susceptibility. And to do that, all we need to remember is that the susceptibility is equal to the permeability minus 1. So if we know that the permeability is 2021, we just have to subtract that, and we get 2020, the value for the magnetic susceptibility.